Hi everyone, and welcome to Document Filters Features Preview. I'm going to be the product manager for Document Filters, and we'll be going over some enhancements in the 25.2 release. So let's take a look at what's new in this release. So first, we've added position metadata to both Markdown and JSON's outputs, bringing spatial awareness to your extracted data. After that, we'll discuss the support for complex tables in Markdown, including multi-line cells, lists, and nested structures, making Markdown more reliable for real-world business documents. And finally, we've introduced a powerful custom OCR integration option. This lets you bring your own OCR engine and plug it directly into our pipeline using a simple callback mechanism. Each of these updates is designed to give you more control, better structure, and greater flexibility when processing unstructured content. So this release introduces positional metadata for Markdown and JSON outputs, allowing each piece of extracted content to be traced back to its original location in the document by page, line, and even bounding box. This is especially useful in AI pipelines, where traceability is key. For example, a document question and answer system can now point directly to where an answer came from in the source file, making the system's output more trustworthy and easier to verify. In content review or summarization workflows, this location data also makes it easier to correlate model output with source material, supporting use cases like redlining, audits, or visual overlays. We're the first to offer this in Markdown for all the file formats we support, which makes it easier to work with in the lightweight systems or when generating data for LLMs. So to use this, just enable Markdown include locations or JSON include bounds, and positional data will be embedded right alongside the content. So this example shows how Document Filters now captures and preserves positional metadata. So on the left is a sample invoice. And on the right, you have some very small text. So let's zoom in a bit. All right, that's a little better. So now you can see the extracted content with bounding box coordinates for each block, line, and table cell. So this gives you full visibility into where on the page each piece of text came from. So now you don't just get the text, structure, and layout, but also the spatial grounding, all without needing to run OCR. So Document Filters now has enhanced complex table support in Markdown, preserving layouts that include nested content like lists or nested tables. So in the past, these tables would often be partially rendered or discarded, forcing teams to recover structure manually or risk downstream errors. But now, complex tables are preserved using sanitized HTML embedded directly into the Markdown output. So this ensures that every cell and list stay intact, even in challenging formats like regulatory filings, scientific papers, or even business reports. For AI systems, this extracts and analyzes tabular data, like risk assessment models or compliance review. This means better data inputs and more consistent results. And for teams who rely on Markdown for its readability and flexibility, this update removes the trade-offs between simplicity and completeness. So we'll now see what that looks like. So on the left, you see the original document, a typical resource allocation plan with nested bullet points, long-form content, and multiple tables. These are the kind of layouts that usually break down during extraction and conversion to Markdown. And then on the right, you see the Markdown output generated by Doc Filters. We preserve every detail, including list items, formatting, and nested structure, by embedding clean, sanitized HTML inside the Markdown table cells. And since HTML is valid Markdown, plays nicely with Markdown renderers. We've added a flexible OCR callback interface that lets you plug into your own OCR engine directly into the Document Filters workflow. This means you can now use OCR tools that are optimized for your specific documents, language, or image quality, whether that's Easy OCR, Tesseract, or a proprietary engine. For example, a team processing scanned forms or multilingual records might already have a tuned OCR model. With this update, they can integrate that model and still output the result in Markdown, PDF, or HTML without extra pipeline steps. In AI-focused scenarios, this also helps when building language-specific document classifiers or form understanding models, where high-quality OCR is critical to good outcomes. The callback interface is lightweight, language agnostic, and designed to work cleanly with your host application, making it easy to extend the value of document filters with OCR that fits your needs. So that's all we had for this video, and I hope you enjoyed this discussion about some of the new features we're bringing you with this release. As we continue to evolve and enhance document filters, we are committed to continuously improving our tools to better meet your needs. Your feedback is invaluable in shaping the future of our product, and we encourage you to keep sharing your thoughts and suggestions with us. For more information on this release and how to implement the new functionality, please check out our blog post at the link on the screen. You can also find detailed documentation and resources about document filters by searching for Hyland document filters at the location shown. GitHub contains sample code and packages for various platforms, while NuGet provides an easy way to integrate doc filters. Explore our demo videos and release previews on YouTube, and find doc filters on the AWS Partner Network, or visit Hyland.com for additional details and resources. Thanks for listening.